Hello and welcome to our Secret Simulator series, part 3. I'm Castillo from ECEAB2 and today we're going to continue our simulation. So, the previous simulation is focused around AC analysis, meaning it only displays the AC steady state, so meaning the value of the AC analysis or the AC voltage is stabilized at that point. So, but actually, there's a transient analysis, meaning it displays that the very first time it receives a voltage, it is actually not stabilized. So it gradually stabilizes to a certain voltage value. So in order to do that, we need to change the voltage of our uh, circuit. So you need to change it into sine and with an amplitude of 1 volt and a frequency of 1 kilohertz. So as you can see, there will be an additional text right here. So we just move it here for better view. And then this line right here, this 100 kilohertz something something. This is the uh, this is the simulation command. So we just need to right click here and then choose the transient. So the stop time is depend will be depending on the circuit on how many cycles it takes or how long it does it take to stabilize the voltage output. So for this circuit, 10 cycles will be enough. So 10. So the rest is okay for the default values. And then since we change our analysis, we click the running one again. So as you can see from the start here before 1 millisecond, there's a peak of 180 voltage, 180 millivolts. So meaning at the start, it doesn't actually outputs straight up in 90 millivolts. So it gradually stabilize here. So as you can see, right around 4 milliseconds, it stabilizes. And in order to compare our voltage input, we just left click on our voltage in wire. So as you can see, there's a big difference right here. So the blue wire indicates the voltage input, so meaning the voltage input is bigger than the voltage output, which is the green line, the smaller one. So in order to determine the lag of the of this between these two, we need to determine we need to add a multiplier for the V out because it is the smaller value. We need a factor that will provide a similar graph to the voltage in. So a factor of 10 will be enough for this one. So as you can see, there's a delay from the output. So the output lags quite a bit. So if we look at our marker for the V for the oh sorry for the V in right around here in the 0 volts, it actually this is the part where it changes angle, so where it reaches a 9 when it experiences a 90-degree phase shift angle. So in order to determine that or to analyze that more accurately, so we will need to change back to our AC analysis again. So because this time we are going to analyze the stabilized part of our circuit. So we just need to right click our simulation command again, choose AC analysis, and we just place the previous value that we put. So 41 points per decade, 10 starting frequency, and 100 kilohertz stop frequency. And we run it again. And as you can see, there's a blue line right here that indicates voltage in. And during this time, we don't need the factor of 10 because we are now analyzing in a more smaller level, on a more accurate level. So we just need we just remove the factor 10. And as you can see, this is the graph. So since we click on the 1 kilohertz before, so you can just click the V out and it will display on the 1 kilohertz location. So as you can see, right around 1 kilohertz, this is where the degree is almost at 90. So meaning this shows the peak voltage and the phase angle that it the phase changes it that the circuit experiences. So as you can see, the magnitude of 20 displays the voltage and the almost 90-degree phase shift angle. Yeah. So that's all for today for our circuit simulator part 3 series. I'm Castillo from ECAB2 and thank you for watching.